Okay, I'm looking for the de Broglie wavelength of an electron beam made up of electrons that have a kinetic energy of 3.2 keV. So if I think about, I have an electron, it's like this, and it's moving really fast, and I know that because remember that kinetic energy is equal to 1/2 mv squared, and I know that the mass is very small, so my velocity must be really big. Now the equation that I want to use is equation Q4.6, and that tells me that lambda is equal to h over 2k m square root of that, or hc over 2k mc squared square root. Now why would I want to use this equation over this equation? And that's because hc I know that hc is 1240 eV times nanometer. I learned that in the last chapter. And I also know this mc squared. This is the rest energy of the electron. And so I know that number is 511,000 eV. So I know those two numbers, which makes it easier than trying to add in h, which it has, times 10 to the negative whatever, and writing in the mass. So I think this equation's easier because I have those values. So that's what I'm going to use. So I'm going to have 1240 eV times nanometer over 2 times the kinetic energy, which is 3200 eV, times, and mc squared is 511,000 eV. So I can cancel out my eV, and this is square root. So I can cancel out my EVs here. I have an EV here, and I have an EV here, and an EV here. So I'm left with wavelength in nanometers, which is right. And then when I do the multiplication, I get 0.022 nanometers. So my my electrons in this beam have a wavelength of 0.022 nanometers, which is very small.